This is the screencast for section 6.3, example 6, using tabular integration again. Evaluate the antiderivative of x cubed sine of x dx. So again, we have a product of two functions of x that are not related by a derivative. X cubed, though, after we take the derivative several times, the degree will lessen and become an easier function to work with. So I can use integration by parts, and of course the directions say use tabular, so we will. Alright, so u, or f of x and its derivatives, are going to start out with x cubed. The derivative then would be 3x squared, 6x, and then finally 6, and then of course everything after that would be 0. Now g of x, or dv, is going to be the sine of x, of course dx, and then the antiderivative would be negative cosine of x. Antiderivative of that would be negative sine of x, and now we're going to change sign again, and cosine of x is the antiderivative. Then sine of x. Alright, so now we're ready to use tabular integration to lay out the antiderivative of x cubed sine of x dx. So I take the first term under f of x and the second term under g of x. So in other words, my u and my v, basically, from integration by parts, and that's going to be a positive term. So I have a positive, meaning I don't have to change it to the opposite, so I have just negative cosine of x, x cubed. And then my next term is going to be a negative or opposite term. So then I have the negative sine of x 3x squared, so that's going to be a plus 3x squared sine of x. Then my next one's going to be a positive or same sign term, so that's going to be a plus 6x cosine of x. And then last but not least is a opposite term, so 6 sine of x is going to be a minus 6 sine of x, and then of course the plus c at the end. The now try problem number 23 says use tabular integration to find the antiderivative, and that would be the antiderivative of x cubed e to the negative 2x dx. Alright, so again I'm going to make my u x cubed, because that one, if I take the derivative, is going to become then a square, and then a first power, and then etc. So x cubed, derivative would be 3x squared, then 6x, then 6, then 0. Very straightforward. Now, that means dv is going to be e to the negative 2x, which is a little bit different. How do you take the antiderivative of e to the negative 2x? And you may already know this, you may already predict what's going to happen, but remember, we can use u substitution. So off to the side here, I'm going to call u negative 2x, then du dx is negative 2. Solve for dx, and I get that dx is du over negative 2, so now I can substitute those in. That would be the antiderivative of e to the now u, and then dx is du over negative 2. Of course, that negative 2 would come out as a coefficient, and I'm just taking the antiderivative of e to the u. So that would be negative 1/2 the antiderivative of e to the u du, which is just negative 1/2 e to the u, which we called negative 2x. So now you can see that each time I take the antiderivative, I'm going to be dividing by negative 2 because I'm dividing by the derivative of u. If I took the derivative of e to the u, I'd be multiplying by the derivative of u because of the chain rule. Well, now I'm undoing chain rule, so I'm going to divide by the derivative of u. So I'm dividing by negative 2 or multiplying by a new negative 1/2. So now the next term is still going to be e, or the next antiderivative is still e to the negative 2x, but now it's going to be positive 1/4 as the coefficient because you're multiplying by another negative 1/2 or dividing by another negative 2, same thing. Then we have negative 1/8 as the coefficient. Then we have positive 1/16 as the coefficient. Now I can start to line up my terms using tabular integration to actually find the antiderivative of x cubed e to the negative 2x dx. So the first one is going to be combining these two terms, and they are going to have the same sign as they would originally. So I have a negative 1/2 e to the negative 2x and an x cubed. The next term is going to be opposite. Now this would be a positive 1/4 e to the negative 2x and a 3x squared, but now I'm going to be subtracting that, and I just combine that to be 3/4. The next term would be the same sign. I would not change it to be the opposite, so 6/8 would of course reduce to 3/4, and then I have my x and then e to the negative 2x. And then the last term would be an opposite term. So 6 over 16 reduces to 3/8 e to the negative 2x, and that would be a minus. And then I have a plus c.